Assalamu alaikum warahmatullahi wabarakatuh. Today we're going to talk about the mean value theorem for integrals and derivatives. First, before we even start, what is the mean value theorem? If f is continuous on the closed interval a to b and differentiable on the open interval a to b, then there exists a number c in a to b such that f derivative of c is going to equal to f of b minus f of a over b minus a. Under here, on the blue and on the green are also the same definitions. On this paper, you will see three types of definitions for the mean value theorem. Before we even flip to the next side, we also have to know that there has to be at least 1 point of C. Now let's go. Over here is, before we even go to the mean value for integrals, we have to look at this graph. If we look at this graph, we have 2 points, point A and point B. To find the slope, we have to look at the line that connects point A to point B. So the line that connects the 2 points is the slope. Now let's move to the integrals. First, here we have the f average of the mean value theorem. 1 over b minus a antiderivative of f of x dx. So what is the f average? It's the average value of the function. This just basically means that you will see some of it in the mean value theorem. Over here is another way we wrote this function over here that equals to the mean value theorem. So what we did is we multiplied this part over here times 1 over b minus a, which will equal to the f derivative of c equal to fb minus f of a over b minus a. So let's say g of x equals to f derivative of x. So g of c equals 1 over b minus a antiderivative g of x dx. This is just basically the mean value for integration. To summarize it is g of x is continuous on a to b, then there exists a c where g of c equals the g average. So let's look at this graph over here. We have point A and point B. If you look at the graph goes up, stops, and goes down, and then goes all the way back up. Over here we have point A, and over here we have point B. So if we look how this line over here connects, and we look at how it connects from one point to another, we'll find the average. And over here we have the average as C. I hope you understood this point. So now let's move to mean value theorem for derivatives. So f of x equals 1 plus cube root x minus 1, and our points are 2 and 9. Before we even start, we have to look at this function, whether it is differentiable, if it's differentiable and continuous. So let's start with if it's continuous. So we said the mean value theorem is f derivative of c equals f of b minus f of a over b minus a. So first, we already have our a and b. We said 2 is our a and 9 is our b. So f of 9 minus f of 2 minus f of 2 over 9 minus 2. First, we find the derivative of our function. So our derivative of this function is going to be 1 over 3 cube root x minus 1 squared. So first, we're going to plug in our 9 and our 2. If we plug in our 9, we get a 3. And if we plug in our 2, we get 2. So after that, we plug in our numbers. 3 minus 2 over 7. We obviously get 1 over 7. Let's go further. F derivative, now this is one crucial point. You have to take your derivative of this function and equal it to f derivative of c. So 1 over 3 cube root x minus 1 squared equals 1 over 7. Now we have to solve this. So first, we're going to multiply x minus 1 to the power of 2 over 3 on both sides. So it cancels out on both sides. I'm sorry, on the left side. So after that, we're going to get 1 equals 3 over 7 x minus 1 to the power of 2 over 3. Now we have to get rid of the 3 over 7. So we're going to multiply 7 over 3 on both sides. After that, we're going to get 7 over 3 equals x minus 1 to the power of 2 over 3. At this point, we're going to have to remove to the power of 2 over 3. So we're going to multiply on both sides to the power of 5 over 2. So 7 over 3 to the power of 5 over 2 equals to x minus 1 to the power of 2 over 5, also to the power of 5 over 2. We're going to also get plus minus square root of 7 over 3 to the power of 3 equals x minus 1. Now we're going to have to move the 1 to the other side. So we're going to get 1 plus minus square root of 2 over 7 over 3 to the power of 3. So now we have to find if the function is differentiable. We found out that the function is continuous. So there is a theorem for a function if it's differentiable. So here, the theorem is that if the root functions are continuous on their domains, over here we have negative infinity to infinity. So first, if we look at the function, the function 1 plus the cube root of x minus 1. Also, if you can put any number underneath a cube root, you can have a positive, negative, and 0. So there is nothing that's going to make this undefined. So this root function is continuous on its domain. Also, well, if it's continuous, basically everywhere everywhere is what that says it's certainly gonna be continuous on the interval 2 to 1. Lastly, we now understand that it's differentiable and continuous. But the main question over here is, what is the difference between mean value theorem of integrals and the mean value theorem of derivatives? So the mean value for integrals is a direct consequence of the mean value theorem for derivatives. And the first fundamental theorem of calculus, and basically to sum it up, is that the result that a continuous function on a closed bounded interval has at least one point where it is equal to its average value on the interval. I'm going to repeat this. It has at least one point where it is equal to the average value on the interval. Thank you for watching, and I hope you understood everything that I have said today.